Today, we're going to talk about 1.4 pairs of angles. Pairs of angles. All right, so let's look at that. Pairs of angles. So if you look in the middle of page 28, there are a couple of different pairs of angles. One's adjacent angles and one's linear pair. Adjacent angles. An adjacent angle is, does anybody know what adjacent means? Adjacent means that it's right next to each other, right? That's what adjacent means. Adjacent means that way. So if I had two angles, like A, B, C, I can say that angle AOB is adjacent to angle BOC. So angle AOB, this angle here, is adjacent to this angle here, which makes sense. They're side by side, right? They're actually they're touching each other, so they are adjacent. If you look at the definition there, it says two angles in the same plane with a common vertex, and a common common side. A common side. This would be the common side here, right? Because this side is in this angle, and it's also in this angle too. Okay? So a common side, but no common interior points. So those are adjacent angles. Okay? Adjacent angles. Yeah, the next thing we'll talk about is what we call linear pairs. A linear pair is nothing more than it's a kind of an adjacent angle, but if you have A, O, B, C.
Mr. On?
Yes.
Kayla told me that the Zoom kicked her out and that she's in the waiting room.
Okay, got it. Thank you. Are you back with us, Kayla? I can see her. She must be back. Okay, so a linear pair is that when you have two adjacent angles, here you have, again, you have AOB and BOC. So AOB and BOC. So angle AOB and angle BOC, again, are actually adjacent because they do share this side and they are right next to each other. Okay, so these two angles are adjacent. But in this case, if you add them together, they become a straight line. In other words, when you add the angles together, how many degrees would that be? Raquel? Can you tell us how many degrees that is?
If I add them together?
Yeah.
180.
180, correct. So when you add the two together, they are linear. If they are linear pairs, they would add to 180 degrees. Okay? All right. So that's what a linear pair is. Okay? So let's look at example number one. Example number one. Tell where the angle is, whether the angles are only adjacent and form a linear pair, or not adjacent. Okay, so let's see if we can draw this out. I have example one. And we have AB. Okay, I have ABE. A, B, E, C and D. C and D. Then I'm going to have angles that are labeled here as 1, 2, 3. 1, 2, 3, and 4. Okay, so the question is, What are these? So angle 1 and 2. Angle 1 and 2. Okay, are they adjacent? Are they adjacent? Kyla, are they adjacent?
Yes,
Why are they adjacent?
because they're right next to each other.
Okay, they're right next to each other, side by side, and also they have to share one side, right? So the side that they would share would be this line right here. And so that's good. So 1 and 2 are adjacent. Are they a linear pair? Do they add to 180 degrees?
No.
Doesn't look like it, does it? Because if they would, then it would be a straight line going up this way, right? So they're not a linear pair, so they're just only adjacent, right? 2 and 4. 2 and 4. Okay, how about 2 and 4? Sophie, what are 2 and 4? Are they adjacent?
No,
Why not?
because they don't share a line.
Well, they do. They share this line right here, don't they? Correct? Does that make sense? Does everybody see that? What is not happening? They are not sharing a,
Side.
no, they're sharing a side. They're not sharing the vertex, right? They have to have the same vertex. Because the vertex over here is C, and the vertex over here is B, right? So you see the difference there? So they're not adjacent. Okay, now let's get 1 and 3. Holden, what about 1 and 3? Are they adjacent?
Yes.
Okay, are they a linear pair?
Yes, because they make 180 degrees.
That is correct. So they are adjacent because they are sharing this side. All right, but they also add to 180 degrees. Okay, all right. All right, let's move along, go to page 29. And on page 29, we have 2 separate different definitions. Complementary and supplementary, okay? So we have complementary. Then we have supplementary. Okay, so if you read the definitions, it says complementary angles, when add together, they add to 90 degrees. Okay? Whereas supplementary, when you add them together, they add to 180 degrees. Okay? All right. So, first of all, you guys, when you read this complementary, it's different than the word complementary. When you complementary, you've heard complementary before. What does complementary mean? Daniel, what does complementary mean?
I actually don't know.
So you go to a restaurant and say the drinks are complimentary. What does that mean?
Oh, it's to give a compliment.
Huh?
Is it to give a compliment?
Well, no. When you say the drinks are complimentary, or you go to a, they say that something's complimentary. It's for free, right?
Oh.
It's additional, and it's just there's no cost to it. That's what complimentary. Now, that complimentary is not spelled this way. This E in the middle becomes an I, right? For that word. So this is a different word. Complementary means that when you add together, they're 90 degrees. Okay. All right. So, Bellin, if I had an angle that was 45 degrees, what would the complementary angle be?
If it was, what was the number again?
One was 45. What would the other one be?
And it was complementary.
Correct.
I think it would be like 45.
Correct. So you'd have to subtract from 90 the 45 to get 45, correct? All right, continue on with you. What if they were supplementary angles? One was 45, what would the other one be?
$135.
Correct, 135, very good. So one from 180, you would subtract 45 to get 35, correct? Good, good job. So that's the difference between complementary and supplementary angles. Okay, all right. So that's good. Example number 2, finding the measures of complements. Okay, we just kind of did that. So let's do example number 2. Example number 2A. Find the measure of complement of m, where m is equal to 26.8. So how would I do that? Max?
You'd subtract 90 from 26.8.
You would subtract 26.8 from 90, right? The other way around. And you would get, let's see, 63.82, 63.2, right? And let's do B. In B, they're giving you an angle that is represented by a variable. So the angle itself is 2y plus what? 20. And to find the supplementary angle from here, you would just subtract this, all this from 180 degrees, right? So this would be what? So how would I go about doing this, Jose?
So first you'd want to combine like terms.
Okay, do I have any like terms here?
Yes, you have 180 and 20.
Okay, so how do I combine them?
So you add them.
I would add them? I have a negative here.
Oh, okay. So
it'd be 180 minus 2y minus 20. Everybody
okay.
why the minus gets distributed out this way? Are we good with that?
Oh, because there's a -1 basically, and then
Yeah, there you go. Good job.
So
consider it a -1 times this, right?
Yeah.
Yeah. So that's how the negative gets. Okay, so now we're here. What's the next step?
So you subtract 20 from 180
So you get
to give you 160.
And then minus just stays there, right?
Yeah.
That's
And
as
then
far as I can go. That's as far as I can go. Good job. All right, great. Okay, so that's how you do that. Okay. So example number 3, using complements and supplements to solve problems. An angle measures 3 degrees less than twice the measure of its complement. Yeah. Find the measure of the complement. Okay. So that's example number 2. Example number 3. We're example number 3 now. Example number 3. If I had, let's say that the angle that I'm looking for is x. So the complementary angle would be what? The complement to this would be 90 minus x, correct? 90 minus x. And so it's, what does it say? It says the angle measures 3 degrees less than twice the measure of that. So the angle, this angle here is 3 degrees less than 2 times this. So 2 times this, and I have to subtract 3 to make it equal to x. Everybody see that? This is the hardest part of this question, to get from here to here, okay? So the mechanics down here is kind of important, but not as important as being able to establish this, all right? It says if the angle measures 3 degrees less than 2 times the complement, because this was the complement, right? This is the angle, this is the complement, right? So it's 2 times the complement, and you would subtract 3 to be equal to the angle itself. Okay, all right. So that being the case, Tyler, go ahead and take us home. Go ahead and finish this out for us. How would I solve this?
Wouldn't you multiply the 2 by the 90 and the x?
Okay, so 180 minus 2x, right? There's a minus here because this is a minus here. The minus 3 carries on, and this is actually x. So what would I do from here, Tyler?
And combine like terms.
Okay, how would I do that?
You would subtract 3 from 180.
So I'm going to get 177. Then what? What about?
Would you?
I haven't done anything. I have to move this over on this side, correct?
Yes.
So I would add 2x on both sides, cancel this one out, and I'm going to have 3x here, right?
Yep.
What's my next step?
Then you divide them both by 3.
So x is going to be equal to 177 divided by 359. So the angle itself is 59, and the complement is going to be what then, Tyler?
31.
31. So let's verify this and see if this works, okay? So this would be, if I 2 times this, what do I get? If I times this by 2, what do I get?
62.
62, and I subtract 3,
59.
59, right? So it is correct, right? So we actually verified by checking our work there. All right, let's flip the page. We have a couple more to go. Okay, example number 4. In example number 4, we have light passes through a fiber optic cable, reflects off the walls in such a way that angle 1 is equal to angle 2, angle 1 and angle 3 are complementary, angle 2 and 4 are complementary. Okay, if 38, find the other measures. Okay. So example number 4. So the light is going to come in this way and get reflected over on this way. And we have angles that are 1, 2, 3, 4. So I have angle 1, angle 2, angle 3, and angle 4. And it gives us, I am given that angle 1 and 2 are equal to each other. Angle 1 is 38. So let's find angle number 2. Since this is 38, right, angle 1 is 38. That means that angle 2 has to be what? The same, right? They told us it's the same, so it must be 38. 38 degrees. We are also told that angle 2 and angle 4 are complementary. So angle 4 would be what? Eliora, what would angle 4 be?
It would be,
Or better yet, how would I figure it out?
by subtracting
Subtracting
90 from 38.
or 38 from 98, 90, right? 90 minus 68.
Oh,
That's what you're trying to say.
My bad.
Okay, so if you do this, you're gonna get 52 degrees. Good job, okay? Which means that obviously angle 3 would be the same way because it's complementary to the same angle. So it's also 52 degrees. Okay, are we all good on that? Any questions there? Okay. By the way, not to get on a tangent here, but this is how a fiber optic cable works, right? On a regular cable, let's say you're running regular electrical wire. An electrical wire, how does the electricity get passed through? Does anybody know?
Isn't it conductivity?
Conductivity, right? So you have electrons that actually go through, right? The electrons go through, and that's how electricity gets passed through, right? What are some of the disadvantages of that? Some of the disadvantages of that is that you actually lose energy, right? Because it takes some energy to get through there, right? So you're going to lose energy that way. Not only that, sometimes the conductor or the wire can get hot, right? And you're going to lose energy off of that heat, okay? Whereas in a fiber optic, the signal comes through and it just bounces off the side of this fiber optic cable. So there is no loss, no energy loss. Not only that, but it's very, very quick. It just happens very quickly compared to electricity, okay? So when you hear about these fiber optic lines, this is what this is, okay? All right, so that's that. Now let's go to the last concept we're going to talk about today. The last concept we're going to talk about today is we have vertical angles. Vertical angles is pretty simple. If I have two lines that meet like this, I'm going to form vertical angles, and vertical angles are, this is a set of vertical angles, okay? And this is a set of vertical angles, okay? So if I have 1, 2, 3, 4, I can say angle 1 and angle 3 are vertical, angle 2 and angle 4 are vertical, and vertical angles are always the same, okay? They're always the same, okay? So let's go to example number 5. And example number 5 says, name one pair of vertical angles. Do they appear to have the same random? Okay, so let's go ahead and see if we can do example number 5. And what do we have? We have E, D, E, D, E, F, G, and H. Okay, so let's see if we can do this. Reeve, how many pairs of vertical angles do I have here?
2.
2. Give me one of them.
FDH.
What?
FDH.
FDH and
EDG.
EDG. What would be the other pair?
FDE.
FDE. FDE. This guy, what's the other one?
GDH.
GDH. Everybody see that? Good job, Reeve. Thanks. So this angle, so we have FDH, this guy, and EDG, this guy here. And then for the other pair, we have FDE and GDH. All right, good job. Okay. All right, so I am done. Are there any questions? All right, so let's see where we at. We started at 9:35. So let's actually take hang on a second.